All right, we're going to pick up where we left off. We're going to talk about angles and arcs. A central angle has the center of the circle as its vertex, and its sides contain two radii of the circle. Okay, so if we have a central angle, an example of a central angle would be ABC. I have a central angle. The angle starts on one of the endpoints of the circle, it comes to the center, and then it comes back out to the edge of the circle. So it makes sense. It's an angle that is formed by using the center of that center point. Okay? Keep in mind, one thing to keep in mind is that if I started at A and I walked all the way around and came back to A, the total number of degrees in a circle is 360 degrees. So that's just one little thing to kind of keep in mind. All right, when we are describing, now that we have an idea of what a central angle is, the central angle is here, and it forms what is known as an arc. So if this is my angle, then the arc that it is formed, it's kind of like tracing out the outline. Here is my center angle, and then the arc is that which is formed when I connect the endpoints of those two angles. So this is the arc. Now, a unique thing to know is that there are two types of arcs. We have a minor arc and we have a major arc. That's that when we're looking at it. And when we're looking at a minor arc, the arc degree measures whatever is equal to that of the central angle, and it will always be less than 180 degrees. So what this little definition means is that whatever is the degree of the center angle, that too is the degree of the arc itself. Whoops, this was 110, so this is 110 degrees. The arc itself has 110 degrees. If it is a minor arc, it has to be less than 180. So when we look at this, we have go from here. We use two letters to name a minor arc, where it starts and where it ends. And again, the order doesn't matter. Maybe it starts at C and goes to A. Maybe it goes from A and goes to C. We're going to use this little kind of a little short, like almost like a parabola, to designate the arc, and then we put underneath it AC, and again you could call it CA. What is the measurement of this arc? This arc measures 110 degrees. Why? Because that's the value of the central angle. The minor arc is going to always equal whatever is the central angle degree. Okay. All right, let's take a look at major arcs. And if we have a major arc, then this is an arc degree. This arc degree will measure 360 minus whatever was our minor arc degree. And a major arc is always going to be greater than 180. If we look at something like this, we have, again, focusing on that central angle. We have this angle here. It's coming in like this. And we're told here that this is 60 degrees. Now, one thing to keep in mind is that if this little wedge, this would be our minor arc because it's small, it is less than 180. So therefore, this one here has to be our minor arc. But we want to identify a major arc. When we identify a major arc, we must use three letters to name that arc. What point did we begin it? What point did we pass through? And where did we end? So if we look at this particular one, ED would be the minor arc. E coming around D this way would be a major arc. But we need to make sure that we can specify which arc are we looking at. Are we looking at the minor arc from E to D? Or are we looking at the major arc going almost all the way around? That is why it is very important that we use 3 letters. So to identify this as a major arc, again, we're going to have that little arc at the top. Where did I start? I started at E. As I traveled, who did I pass? I passed through this point here, and that was labeled as F. And as I continue on, I stopped at D. Okay, so I'm using the 3 letters. Where did I begin? What point did I pass through? And where did I end? Now I could very easily also call this start at D, pass through F, and end at E. Either one of these would be fine. They're really one and the same. All right, now I need to figure out just what is the measure of this arc. What is the degree measure of that arc? If this little wedge is 60 degrees, then I need to figure out just what is this degrees. How do I get that? Well, if the total is 360 minus whatever is my minor arc, I'm going to subtract out the 60. And so my answer here is that that major arc is going to be 300 degrees. All right, there is one unique arc, kind of unique to itself, and that is a semicircle. The semicircle, this arc degree will equal 360 divided by 2. Since the semicircle, this diameter line cuts our circle into 2 equal parts, so half of it is on one side, half of a circle on the other side. That's our semicircle. 360 degrees is total, divide it by 2. Or we could just simply say that the semicircle is 180 degrees. Okay? Again, if we are going to name a semicircle, because there are 2 semicircles here, we have one coming around this way, and we also have one coming around this way. We need to distinguish just which semicircle am I talking about. So again, I need to use 3 points. If I am looking at and describing the pink semicircle, then again, I'm going to use a point that I start, a point that I go through, and a point that I end. So this would be J, K, L. Again, I could also call this L, K, J. They're one and the same. If I'm looking at naming this semicircle, then again, I'm going to, where did I start? What point did I pass? And where do I end? So this one would be JML, or I could call it LMJ. No matter what, all of these is going to equal 180 degrees. They're half of a circle. All right, let's put some of this practice to good work. If we look at the problem here, we're going to take a look at this problem here, and we're going to solve for x. So we've got to look at what is going on and then try and figure out where to start. What are some things that we see? And again, some old lessons from the past, we might look at linear pairs, we might look at vertical angles, anything we can think of to try to help us start. You know, might be able to look at various different things, different ways. There's definitely more than one way to work this. It just depends on what you're looking at. If I take a look at, say, this diameter. Now we know that the diameter is going to cut the circle into 2 equal parts. So I can think about this if this part here is 20x and this part here is 5x plus 5, then I can go ahead and set that equal to 180. So I could start this as saying 20x plus 5x plus 5 equals 180. Maybe I didn't really see that and maybe I focused on this line. Okay, so if I'm looking at that line, then I would know that these three all have to, again, add up to 180. So maybe I'm looking at 8x minus 4 plus 13x minus 3 plus 5x plus 5 equals 180. So maybe perhaps that's what I saw. Maybe I realized that this angle and this angle are vertical, and maybe I'm looking at trying to get this line, but on the other side. So there's a few different ways that I can solve this. Once I get this together, I would combine like terms. So this here would be 25x plus 5 equals 180. Then I would go ahead and solve. I would subtract 5 from both sides. I'm running out of room here. 25x equals 175. And then I would go ahead and divide by 25, and I'm going to find that x is equal to 7. If I set it up this particular way, again, I'm going to combine some like terms. And I have 8x and 13x and 5x, and that gives me 26x. I have a -4, a -3, and a 5. That gives me a -2, and that all equals 180. That gives me 26x. I'm going to add 2 to both sides. That gives me 182. I'm going to divide by 26, and wouldn't you know, x equals 7. So no matter which way you set it up, you're going to still get the same answer. All right, if we look down here, we've got some pieces of information. We want to try and think about what we're given. We're given that angle NPM, this one right here is 46 degrees. We know that PL right here is going to bisect KPM. So this angle and this angle are the same. We see where some segments are perpendicular, and that's already marked in the diagram. And we need to figure out what is the measure of OK. So what is the measure of arc OK? Where is OK? It is from here all the way over to here. Now, if we could figure out what is our central angle from O to K, if we can get this angle, the central angle degree measure, then we'll also have the arc measure. So they are one and the same. If we think about this right here, we see that we have this diameter. Okay, and then with that diameter, if this is 90 degrees, then it makes sense that this piece has to be 90 degrees as well. Here now forms my angle and my arc OK. If this is 90 degrees, then the measure of this arc also is going to be 90 degrees. I want to find the measurement of LM. LM is right here, so I want to find this angle measure now. This pink little wedge is the one I'm looking for. Again, I know that this is 180. I have 46, and I know that these two are congruent. So in order to do this, I can take that 180, I can subtract the 46. That's going to give me 134, and I'm going to divide that into two pieces. And so I see that this piece here is going to give me 67 degrees. So this arc, LM, is 67 degrees. And then the last one I have is JKO. So I'm starting at J. I'm going through, where am I? I'm starting at J. I'm going through K, and I'm ending up at O. So I'm starting here, coming all the way around and coming to here. If I am doing that, then I need to, one of two things. I can think about all of these pieces. I know that this is 90, this is 46, this is 67, this is 67, and this one here is going to be vertical, so this is 46 as well. So I could add up all those pieces. I'm starting at J and I'm coming around to here. So if I was to add up all of those segments, I would have the 90, I would add the 46, add the 67, add the 67, add the 46, and I find that this angled degree of that distance around is 316 degrees. All right, if you, again, we're going to stop here. We have one last thing to look at. We're going to stop the video here. And if you have any questions, again, as always, please let me know.